Question number 1. Which command on access to port 1/1/4 will enable connectivity between PC1 and server 1 without any routing enabled in the network? Take a look at the second question under configuring wired network solutions. Refer to the exhibit. What commands will successfully enable the SVI for VLAN 100 on interface 1/1/1 to produce the results displayed in the command show IP interface brief in the exhibit below? Let's go to the next question. Question number 3. What are two features in a two-tier design that are implemented at the access layer? So we have to select two answers. Next question. Question number 4. What are two features of three-tier designs? Next question. Question number 5 under network architectures and technologies. Which statement accurately describes the TCP three-way handshake? Question number 6. What does link aggregation provides? This question is under functions and features of Aruba products and solutions. Let's move on to question 7 under functions and features of Aruba products and solutions. Which two statements accurately describe stacking with Aruba switches? Hello everyone. Welcome to today's online class from 591lab.com. Today we will be discussing sample questions of Aruba Certified Switching Associate exam. In this session today, you will understand few concepts related to Aruba wired solutions. Before I move on, let me introduce the 591lab.com. 591lab.com is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we will be discussing few topics such as configuring wired network solutions, network architectures and technologies, functions and features of Aruba products and solutions, optimize Aruba wired solutions, troubleshooting, management, monitoring, and operate Aruba solutions. From Aruba Certified Switching Associate Exam Objectives. Okay, let's look at the first question under configuring wired network solution. Question number 1. Which command on access to port 1/1/4 will enable connectivity between PC1 and server 1 without any routing enabled in the network? I have simulated this scenario in GNS3 using Aruba OSCX simulator. Let me show it to you. Okay, I have configured the simulation equivalent to the question. I have used access 1 and access 2 switches, PC1 and server 1. So let me show you the access 1 configuration. I have assigned 1/1/3 interface to VLAN 20. That is, PC1 belongs to the VLAN 20. And 1/1/7 is configured as a trunk port, and I have allowed all the VLANs. So I have created these VLANs here on 1020 to 255. All the VLANs are allowed, and 1/1/3 is assigned to VLAN 20. So similarly, let me show you the access 2 switch. I have configured the same VLANs. The show run, the port 1/1/7 is configured as a trunk and allowed all the VLANs. So 1/1/4, which is connected to the server 1, is not that configured. So the requirement is to have connectivity from PC1 to server 1. So as of now, if you ping PC1 from PC1 to server 1, it will not work. Ping 10.1.20.200, that is server 1. So it is not pingable. So PC1 to server 1 connectivity is not there. So to have connectivity from PC1 to server 1, we have to extend the VLAN 20 via this trunk towards this port 1/1/4. So what I have to do to fix this issue, I have to configure interface 1/1/4 as part of VLAN 20. So let me do that. So first I have to make it layer 2 port. By default they are routed ports. I disabled routing. I make the port no shut, which is VLAN access 20. I have configured port 1/1/4 as part of VLAN 20. Now we should be able to ping server 1 from PC 1. Yes, it works. So I'm able to ping server 1 from PC 1. So what I have done to fix the issue is to make the interface 1/1/4 as part of VLAN 20. Let's look at the answers now. Option A, under access 2 switch, under interface 1/1/4 VLAN access 20. So that is one I have done. You have seen my configuration. So I have made 1/1/4 interface as part of VLAN access 20. So option A is correct, but let me check the other options as well. Option B, under 1/1/4 VLAN 20 untag 1/1/4. So there was no such command. Option C, config 1/1/4 VLAN access 110. No, there is no such command. Only one VLAN can be configured as access. Under 1/1/4 VLAN trunk allow. No, that is also wrong. Option D also wrong. Because 1/1/4 should not be a trunk port. So the correct answer is option A. We'll move on to the next question. Take a look at the second question under configuring wired network solutions. Refer to the exhibit. What commands will successfully enable the SVI for VLAN 100 on interface 1/1/1 to produce the results displayed in the command show IP interface brief in the exhibit below? Let me show you the simulation for this. In my simulation, I have taken one switch. I just want to create that VLAN 100 and show the output. So here, this is the default switch. Let me show you the VLANs. So nothing is configured. So let me configure that VLAN as per the question. VLAN 100. I have created the VLAN 100. Also under interface 1/1/1, I have made it. I had to do no routing to make it layer 2 port, no routing, and no shut to make it up. And the question asked to create the SVI for VLAN 100. For that, I have to do. Also under interface 1/1/1 should be configured as a trunk port. VLAN trunk allowed all, so I am allowing all the VLANs, and by default VLAN trunk native 1 should be there. If I check the configuration, let me show you the showdown. So interface 1/1/1 it is layer 2 and no shut. Native VLAN is 1, allowing all VLAN on the trunk. And VLAN 100, let me show you the VLAN 100 is configured. Now the requirement is to enable the SVI for VLAN 100. Let me configure the SVI. Interface VLAN 100, make it shut. As per the question, I have to assign 10.1.1 to this SVI 100. /24. This is how you assign a IP for the switch virtual interface. So now I have done that. Let me show you the show IP interface brief. Yes, you can see the VLAN SVI100 is having the IP 10111. It's up. So this is how you enable the SVI. So let me check the answers now. Option A, under configuration mode, I am creating interface VLAN 100. Yes, that is correct. Then under that SVI, I have assigned the IP address 10.1.1/24. So this looks correct. Option A looks correct. Let me check the option B. Actually, interface VLAN configuration mode, VLAN 100 and assign. So this is wrong. There's no such configuration. Option C, interface 1/1/1, and no, we are not. If you configure routing under this interface, so we are making this interface 1/1/1 as a routed interface, but we are not doing that. So we have to configure no routing under interface 1/1/1. Routing configured under interface 1/1/1. Option C also wrong. So option D, interface 1/1/1 VLAN trunk permit VLAN 100 and interface VLAN 100 IP address static. So there's no such command. So the command is wrong. So option D also wrong. So the correct answer is option A. Let's go to the next question. Question number 3. What are two features in a two-tier design that are implemented at the access layer? So we have to select two answers. This is the Aruba documentation on network architectures. In two-tier design, you have access layer and core layer. This is the core layer and this is the access layer. We call this architecture as collapsed core because there's no distribution layer. Only two layers, core layer and access layer. In access layer, all the connectivity and functions related to end-user devices, end devices such as PCs, access points, IP cameras, printers, scanners, IoT devices, and any other endpoint devices are served here using these access switches. So layer 2 switches are used in the access layer. These are layer 2 switches. In core layer, switched virtual interfaces and layer 3 routing are configured. So when we configure switched virtual interfaces, they act as gateways for these VLANs, and inter-VLAN routing and whatever other routing required with the external nodes are configured in core layer. For example, external connectivity to internet and IPv4 are provided at core layer. Let's look at the answers. Option A, deep packet inspection. In the access layer, the deep packet inspection is not done. Deep packet inspection can be done at core layer. Wherever you have a firewall, and if you have a Aruba mobility controller, if it is a tunnel node setup, then deep packet inspection can be done at core layer. So option A is wrong. Option B, VPN access. VPN access also terminated on the core layer, not on the access layer. Option B is wrong. Power over Ethernet. Yes, power over Ethernet is required to power up access points, sometimes IP cameras, whatever the PoE required devices. So that PoE should be provided by the access switches in the access layer. So option C is correct. Option D, endpoint access. Yes, endpoints are connected to access switches in the access layer. So endpoint access is provided by the access layer. So option D is correct. Option E, WAN MPLS connectivity. So the WAN connectivity is provided at the core layer. So external connectivity such as MPLS, WAN, internet, whatever the external WAN connectivity is provided at the core layer. So option E is wrong. So the correct answers are option C and D. Let's move on to the next question. Question number 4. What are two features of three-tier designs? It is about three-tier design. In 3-tier design, there are 3 layers, namely access, distribution, and core. 3-tier design is used in large networks where physical wiring layout is not suited for 2-tier design. It could be a large number of access layer switches distributed among multiple buildings. Then those access layer switches need few aggregation points, for which we call distribution layer. In 3-tier design, layer 3 services are moved from core layer to the distribution layer. Switched virtual interfaces are defined in distribution layer, and high-speed layer 3 links are established between distribution and core layers using dynamic routing protocols such as OSPF. Apart from that, access control lists are implemented at distribution layer by reducing the load on the core. 3-tier design is scalable as it is possible to add more distribution layer switches when the access layer grows by increasing the number of links between the core and distribution. Okay, let's look at the answers. Option A uses only layer 2 access on the access and the core with layer 3 routing and access control provided at the distribution layer. Core doesn't provide the layer 3 routing, so layer 3 routing is provided by the distribution layer. So option A is not correct for the tier 3 design. Option B, do more scalable design over by leveraging a distribution layer to handle layer 3 routing and access control in large deployments. Yeah, it looks correct. The distribution layer is providing layer 3 routing as well as access control. Option C removes the distribution layer in favor of a spine and leaf design used in modern data center deployments. It's not related to this 3-tier design. A spine and leaf design is applicable for the data centers, and there's no removal of distribution layer in 3-tier design. Option C is wrong. Option D is considered legacy by requiring a large flat layer to broadcast domain from core to access and should be avoided. It's wrong. There's no large flat layer to broadcast domain from core to access. It is wrong. Option D is wrong. Option E adds a distribution layer to free up resources from the core for improved performance and routing throughput. Yeah, it looks correct because we are freeing up the resources from the core to make the core is having high speed connectivity between the distribution and core, and so the core improves its performance and routing throughput. This is correct. So the correct answers are option B and E. Next question, question number 5 under network architectures and technologies. Which statement accurately describes the TCP three-way handshake? TCP three-way handshake is a process which is used in a TCP/IP network to make a connection between server and client. SYN, that is synchronize, used to initiate and establish a connection. ACK, that is acknowledgement, helps to confirm to the other side that it has received the SYN. SYN ACK is a SYN message from local device and ACK of the earlier packet. Let's focus on the three-way handshake shown here. Client begins the connectivity by sending the TCP SYN packet to the server. The packets contain a random sequence number, for example here it's M, that indicates the beginning of the sequence numbers for data that the client should transmit. After that, the server will receive the packet and it responds with its sequence number. Its response also includes the acknowledgement number, that is client sequence number incremented by 1. Here it is M plus 1. Client responds to the server by sending the acknowledgement number, that is server sequence number incremented by 1, that is N plus 1. Then the session is established. Let's go through the answers. Option A. It is a process of breaking larger files into smaller segments that are assigned sequence numbers for recovery. There's no such breaking larger files into smaller segments. So option A is wrong. Option B. It uses flags such as start, stop and resend between two endpoints to guarantee lossless traffic flows. No, it's not correct because there's no using such flags as a start, stop and reset. So option B is wrong. Option C. It is a method of establishing a reliable bidirectional connection between endpoints before sending user payloads. Here it looks correct because it is a reliable connection and it's bidirectional also between the endpoints before sending user payloads. So C looks correct. Let me check the D. Option D. It is a method of connecting three endpoints in a ring topology where a token is passed to avoid collisions. No, this is not correct because the question is related to TCP three-way handshake. So option D is not correct. So the correct answer is option C. Let's move on to the next question. Question number 6. What does link aggregation provide? This question is under functions and features of Aruba products and solutions. Let's understand the link aggregation by looking at this simulation. For this simulation, I have used two switches and I have connected two PCs also. But we had to focus on this link between these two switches. So we are going to aggregate these two individual links and make this as a link aggregation. So let me configure this link aggregation on switch 1. So in switch 1, I will make these 1/1/1 and 1/1/2 as layer 2 ports. No routing, then it becomes layer 2 ports and I will make them up. No shut. I'll keep the VLAN 1 as it is. I'm not going to configure multiple VLANs. This is just to simulate the link aggregation. And I'll create interface lag 1. This is the link aggregation group. Interface lag 1. I make it no shut as well. Then LSCP mode. What are the available options? So I'll make it active. So it will negotiate. So LSCP mode is active. Similarly, I'll configure the same thing in the switch 2 also. Create interface lag 1, make it no shut. LSCP mode active. Then I have to make these individual interfaces are part of this lag 1. So I'll go to these individual interfaces. I'll select them at once. And I'll make them as part of lag 1. Let me check the configuration here. I have created a lag 1 interface. I make it unshut, and each individual interfaces is 1/1/1 and 2. They are part of this lag 1. Similarly, I have to in switch 1, I have to make them part of lag 1 also. Let me check the configuration in switch 1 also. Lag 1 is created, it is up. LSCP mode active, so 1/1/1 and 2 they are part of lag 1. Let me check the show interface lag 1. So you can see the speed. See, each individual link is 1 gig link. So you can see the lag 1 interface is having 2000 Mbps, that is 2 gig. The bandwidth is doubled. So these are the member boards of this aggregation interface. The aggregation is up. So let me show you some other commands. Show LACP, any other command, show LACP aggregates. Yeah, that is another thing. Like one, these are the interfaces, it's active. And any other your interface lab 1 brief. Let me show you the full output here. Yes, you can see the lag 1 mode is routed, it's enabled, and is 2000 Mbps. So actually our lag interface, we have to make it no routing, because our intention is to configure this lag as phase lag 1. This is no routing. Similarly, in the switch 2 also, that we need a layer 2 lag. So interface lag 1 brief. Yes, now it is access. Now it's a layer 2 lag. It's access and bandwidth is doubled. Okay, now you have seen the link aggregation. So how the individual links can be bundled and bandwidth can be doubled. Let's look at the answers. Option A, no load balancing. Actually, link aggregation provides load balancing. So option A is wrong. Option B, improved bandwidth between switches. Yes, because bandwidth is doubled after adding 2 member links into the aggregated links, the bandwidth was doubled. So if you add more links, the bandwidth will be increased as according to the number of links. So option B is correct. Option C, faster convergence than spanning tree. Yes, because there's no need to go through those spanning tree states. Because spanning tree will see this link lag interface as a logical one link. So there's no need to go between these states of the spanning tree. So option C is correct. Let me check the option D. Support for up to 2 active ports to be bundled together. Actually, there are more than 2 active ports can be bundled. It's not up to 2, it's more than that, maybe up to 8. So option D is wrong. Option E disables spanning tree between switches. It is not disabling spanning tree. Instead, spanning tree will see this bundled link as a single link. So that is the only thing happens within the spanning tree. So it will not disable the spanning tree. So option E is wrong. So the correct answers are option B and C. Let's move on to question 7 under functions and features of Aruba products and solutions. Which 2 statements accurately describe stacking with Aruba switches? Let's understand stacking methods of Aruba switches. There are 2 methods called VSF and VSX, Virtual Switching Framework and Virtual Switching Extension. In VSF, management, control and data plane are shared. In VSX, management, control planes are not shared but synchronized. Ethernet links are shared. In VSX, only 2 switches can be stacked because this method is applicable for 4 switches and data center top of rack switches where only 2 switches are required. In other situations where more than 2 switches need stacking, VSF is applied. Both AOS and AOS-CX switches support VSF, but VSX is supported by AOS-CX switches only. Aruba 6200 and 6300 switches support VSF. 6405, 8300 series, 8400 series, 10,000 series, those switches use VSX. For VSF, same switch model or members in same series are required. So you cannot do VSF from one switch from AOS-CX and another switch from AOS. You cannot do VSF. It should be in the same series. So you cannot do VSF with 6200 and 6300. Both should be in same series. We'll check the answers. Option A. The VSF feature is not compatible between AOS-CX and AOS platforms. Yeah, that looks correct because they are not compatible. Option B. VSF and VSX are stacking option with the AOS-CX 8320, 8325, 8400 and 6400 models. Now it is not correct because VSF is not supported by these models. So option B is wrong. Option C. A VSF stack is allowed between an AOS 5400R and an AOS-CX 6400. This is wrong because 6400 doesn't support VSF. Option C is wrong. A VSF stack is allowed between an AOS-CX 6300M and 6300F switches. Yes, because they belong to same 6300 series, so VSF stack is supported. So option D is correct. Option E. VSF is a core or aggregation layer stacking technology due to the high resiliency of sharing a single control plane. It's a single control plane, but VSF is not a core or aggregation layer stacking. It's more on access layer stacking, but not for a core layer stacking. So option E is not correct. So the correct answers are option A and D. Let's go to the next question. Question number 8 under Optimize Aruba Wired Solutions. What are the commands to disable SSH and HTTPS services from the default VRF? Let's check these commands in the simulation. So in the previous simulation, let me log into one switch 1. Let's consider switch 1. And we'll see how to disable SSH and HTTPS. So under configuration mode, no SSH. So what is the next available command? No SSH server. And then VRF is required. So we have to define the VRF, and then the VRF name. So it should be default. So this is how we can disable the SSH server. So this is the syntax. No SSH server. We have to define the VRF. Similarly, how to disable the HTTPS server. So it is HTTPS server. And again, we have to define VRF and VRF name as before. So no HTTPS server VRF. And so here under SSH, there's no option, but in HTTPS, there's an option just to enter no HTTPS server and press enter without defining VRF. But here in SSH, no SSH server, it is compulsory to define the VRF. But under HTTPS server configuration, disabling, we can just enter without defining VRF, but we can define the VRF also. Okay, now we have seen the syntax of these commands. Let's check the answers. Option A, in the configuration mode, no SSH server, but VRF keyword is missing, VRF and the default. So that is missing. So option A is wrong. Option B, no SSH server, VRF default. That part is correct. Let's check the HTTPS. No HTTPS server, VRF default. That is also correct. So option B looks correct. Let me check the option C. In user privilege mode, you cannot configure these commands. We have to go to the configuration mode. So no SSH server VRF default, no HTTPS server VRF. So this is not possible in the privilege mode. We have to go to the configuration. So option C is wrong. Option D, the configuration mode, no SSH server enable. Now, there's no such command. This command syntax is wrong. So option D is wrong. So the correct answer is option B. Let's go to the next question under troubleshooting. Question number 9. The customer has 185 developers testing computer games on the network. Which two actions resolve broadcast storms? Need to understand how the broadcast storm is created. In this image, you can see there are three switches interconnected. So there's redundant links among these three switches. And you have two PCs, PC1 and PC2. So when PC1 sends broadcast traffic, it will be sent out by the switch 1 to all ports, that is towards SW3 and towards SW2, except back to PC1, to all ports except the port that it receives that broadcast traffic. So then switch 2 also does the same. So it is sending the broadcast traffic here and to PC2. So now switch 3 is receiving the broadcast traffic from SW2 as well as from SW1 in this direction, from SW2 in this direction. So SW3 is receiving the broadcast from both directions. So then once the SW3 send again the broadcast traffic back to SW1, so when the SW3 receives the broadcast traffic from SW2, that traffic is sent into SW1 again. When SW3 receives the broadcast traffic from SW1, it sends that traffic back to SW2. So then this cycle continues and making a broadcast storm in the switching network, while the network cannot perform the data transfer that it is supposed to do. To avoid such situations, spanning tree is used. So it will automatically disable redundant ports to break the switching loop so that broadcast storm won't be created. So spanning tree will create one of the non-root port as alternative port, and it will put that port in a blocking state. So one port will be the blocking state, so there will be no redundant path. So only single path will be active for certain VLANs. Let's look at the answers. Option A. Manually disable the redundant link to immediately resolve the impacted portion of the network. Yes, by manually disabling a redundant link will immediately stop the switching loop. So it will stop that broadcast storm. So option A looks correct. Option B. Setting switch ports to half duplex will resolve broadcast storms using carrier sense multiple access collision detection. That is wrong. By making the half duplex, that is making the ports half duplex, will not solve the issue. So option B is wrong. Option C. Enable single area OSPF on all layer 2 switches but do not enable routing. So that statement is also contradicting, because how do you enable OSPF without enabling routing? So option C is wrong. Option D. Utilize spanning tree to dynamically block designated ports in addition to alternate ports. Actually, spanning tree will dynamically block the alternate ports, not the designated ports. So option D is wrong. Option E. Utilize spanning tree to dynamically disable all redundant links in a segment. Yeah, that looks correct, because spanning tree will dynamically disable the redundant links, all redundant links in a segment. So the correct answers are option A and option E. Let's go to the question number 10 under troubleshooting. You need to remote into an AOSCX switch using SSH in order to capture the management IP address for future connections. Unfortunately, you misconfigured the IP address and are now locked out of the switch. What command could you have issued before making changes that would have recovered the original switch configuration after 10 minutes? Here the requirement is to have a mechanism to go back to the previous configuration after scheduled time, such as 10 minutes. So that misconfiguration done were not saved into NVRAM permanently. Look at my simulation and we'll check what each command does as per the answers. Let's look at the command syntax using this checkpoint command. checkpoint. What are the available options? So checkpoint rollback. So checkpoint rollback with the name, that is the checkpoint name. So checkpoint will roll back to this particular checkpoint name. So that is not the correct answer. That is to revert the configuration to a particular checkpoint. So what are the other options? Checkpoint auto. What is checkpoint auto? So then it is saying lapse time is minutes. Okay, so if we configure checkpoint auto and some number of minutes, then automatically it will go back to the previous configuration after that passing the number of minutes. So checkpoint auto 10. So that means after 10 minutes it will go back to the previous configuration. This will solve the this is what question is asking to do. Let's check the answers. Option A, checkpoint rollback 10. So as per the syntax, we have seen checkpoint rollback command and the next whatever number or name, this is the name of the checkpoint, some checkpoint. So the idea of this command is to roll back the configuration to this particular checkpoint name. Here the checkpoint name is 10. So but our the requirement of the question is not that. So after 10 minutes we have to go back to the previous configuration. So this command is not correct for this scenario. So option A is wrong. Checkpoint auto confirm 10. So you have seen the syntax. Checkpoint auto, then there is no confirm keyword. So option B is wrong. Checkpoint auto 10. Yes, we have seen checkpoint auto 10 is correct because after 10 minutes it will go back to the previous configuration. So option C looks correct. Option D, boot system secondary 10. No, this is not correct. So this is not relevant to the configuration what we require. So the correct answer is option C. Let's go to the next question under manage, monitor and operate Aruba solutions. Question number 11. What is an available command on an Aruba or AOSCX switch that could back up the secondary image to a secure remote repository? Let me show you these command syntax in my simulation. Okay, let me take one of the switch and let's check the syntax of this copy command. What are the available options? Copy, then because we have to back up the secondary. So the copy from the secondary switch image. Okay, secondary is available. Copy secondary. Then the remote URL. So SFTP, then colon and user at, then IP and port number and the file. Or then if it is TFTP, the TFTP, then IP, whatever port and file name, SCP. So these are possible options with copy secondary. So the copy secondary means copy from the secondary switch image. Answer using backup. Is there any command like backup? No, there's no such command. No backup command. Only the copy command, and it is copy secondary, copy from the secondary switch image. So other options are not relevant. Let's look at the answers. Option A, backup secondary SFTP colon / actually backup command was not there. So to copy from the secondary image to a secure repository, you had to use the copy command. So there was no backup command. So option A is wrong. Option B, copy secondary SFTP colon / admin. Yes, username is required. Admin at the IP of the remote server and the file name. So option B looks correct. Option C, copy SFTP colon admin, file name and secondary keyword at the end. That is wrong. So secondary keyword should be in the after the copy command. So copy secondary should be there. So option C is wrong. Option D, copy secondary the DFTP colon / admin. So there is no username required for the DFTP. IP address of the remote DFTP service required and the file name, but there is no username required. So option D is wrong. So the correct answer is option B. We have reached the final question from Manage, Monitor and Operate Aruba Solutions. Question number 12. Refer to the exhibit. The command show LLDP neighbor info gets typed into access 1. All switches are Aruba OSCX switches. What is the output of this command? Let me show you this setup in my simulation. I have created this setup according to the question. I have used 3 access switches and I have connected using the same interface numbers as per the question. And let me show you the configuration in the access switches. In the access 1, port 1/1/2 is part of VLAN access 1 and 1/1/3 also VLAN access 1. So entire switch network is part of VLAN 1. Similarly, access 2 also having similar configuration. So these ports are part of VLAN access 1. They are layer 2 ports. Access 3 also same. 1/1/5 is part of VLAN 1 as layer 2 port. So all these connections are layer 2 and they are in VLAN 1. So the question asked to issue the command show LLDP neighbor info in access switch 1 and see the output. So let me issue that command, show LLDP neighbor info. So then it shows these output. So you can focus on this output. So local port is 1/1/2. That is 1/1/2 port of the access 1. That is the local port. The CIB. The port ID is 1/1/1 of one of the neighbor. That is the 1/1/1 of the neighbor. And port description also same. Then TTL value 120 and system name. System name is access 2. So this is the neighbor of access 1. This access 2 is the neighbor of access 1. So it is showing the directly connected neighbor. This access 2 is shown. We can check again this output. This is the output you can see. The directly connected neighbor and its name. Okay, let's look at the answers now. Option A, you can see the local port is 1/1. Actually, this should be the 1/1/2. Access 2 port is 1/1/1. So the port ID should be 1/1/1. So option A is wrong because the port numbers are different. Option B, there are access 2 and access 3 are shown, but it should not be correct because access 1 will show the LLDP neighbor of access 2.1. So option B is wrong. Option C. Option C also showing access 2 and access 3, but that is wrong. Only direct connected neighbor will be shown here. Option D. Local port 1/1/2. Okay, that is correct. The CID. Port ID and port descriptions are, that is the directly connected neighbor. 1/1/1 and TTL 120 and system name access 2. That is neighbor name. That is correct. So option D is correct. That concludes our training for today. I hope you found this overview of Aruba Certified Switching Associate exam topics helpful. We have discussed sample questions covering the areas such as configuring wired network solutions, network architectures and technologies, functions and features of Aruba products and solutions, optimize Aruba wired solutions, troubleshooting, management, monitoring and operate Aruba solutions. Be sure to check out 591lab.com for more online courses, practice exams and training materials to continue your certification preparation. You can also visit www.591cert.com to learn more about our full suite of services. If you have any questions or concerns, please don't hesitate to contact us. Thanks for joining today's class and I wish you the best of luck on your certification journey. Have a great day.